Hey guys, welcome to my vlog.
So, for today's objective, I'm going to test my Rubik's Cube machine first, then I'm gonna explain it in terms of physics. So, let's start. So, this is my energy graph of the Rubik's Cube machine. Here it's a brief drawing of my Rubik's Cube machine. And the steps are labeled, and these are my energy graphs again. So first, let's start with the first to sixth step. Here it's a gravitational energy, and for the first step, it will just roll flatly. So, and then it will go down like straight in a pipe, and then it will go down from a ramp, and then the dominoes will fall down too. The thermal energy will also increase, but it especially increases when it hits the ramp on the fourth step, and then it will hit the dominoes too, so it increases really high. And for the kinetic energy, it's also going to increase, and so yeah, it's like this and goes up from the pipe and from the ramp and to the dominoes, yeah, things like that. And second, it's just a 7th step to the 12th step. Oh, sorry. Here, the gravitational energy, because there's no more space, so for the thermal energy, I'm just gonna start in the middle, and there's the kinetic energy. So, and it would just go down, because the cylinders and the balls are rolling down to the ramp, and it hits the hammer and another cylinder, which are like flats actually. And for the thermal energy, it keeps going up, but it keeps hitting something, so it goes up rapidly. Like here, it hits a hammer, so it goes up really high. And the kinetic energy, it is also going to increase, but in the ramp it increases like in the middle, and then it slows down a little bit, and when it hits the hammer, it hits the cylinder and the ball, it also increases. Yeah, okay. So last but not least, my 13th step to my 19th step. On my 13th step is the ramp, and it hits the tape roll, so it goes up really like straighter, and the dominoes and the pulleys and the levers are hitting each other, so it also goes high. And for my gravitational potential energy, the Rubik's Cube machine is going down, so, and for the 14th step to the 17th step, it's on the floor, so it's like nearly zero. And the pulley part, it increases again, and it decreases when it hits the lever, and it goes up a little bit when the other end of the lever tilts up, and it falls again. So for the kinetic energy, it goes down. It goes up when it hits and moves, and especially when it falls, when the cup here falls onto the lever. And then for a while, it just stays and fall because it's going to an end. Okay, so that's it, and take a look at it. Now I want to talk about the fourth step, is the inclined plane, where friction mostly occurs. What's really weird about it is friction is supposed to slow the Rubik's Cube machine down, but actually for these parts, I always find it too fast. Like the ball will always be overspeeded, so it's always troublesome to control the friction. Yeah, and that's about friction. Now I'm gonna talk about the domino step, which is here. a 15 to 16 step, it's quite a large domino, so it falls down slowly. You know, the larger the surface area is, the more slower it will fall down. Yeah, and so to make it speed up, I'm gonna use smaller dominoes maybe, but I think so far
The mass of the ball is 19 grams. So, and the ball falls in 0.5 seconds. So it times the gravity and times 19 kg. So it's the force, and then divided by 100 kg. Then that's the result that we want.
So this bug is 28 centimeters.
So it times together and equals the area, and the area divided by the force equals the pressure.
Centimeters wide. For next week, I'm gonna revise this video because it will be my last video. So I'll see you next week.